Right now, at the very edge of everything we can see, something impossible is happening. Light that has traveled for billions of years is finally reaching us, carrying secrets from the boundary of existence itself, and what it reveals is stranger than anything you could have imagined. The universe has an edge, but it is not a wall. It is not a barrier. It is something far more unsettling and far more beautiful. If you find yourself curious about what lies at the boundary of reality, consider subscribing and hitting that notification bell. You will want to join us as we venture deeper into these cosmic mysteries together. But what exactly is the edge of the universe? Is it a place you could travel to? A line drawn in the cosmic sand? Or is it something that defies our everyday understanding of what an edge even means? Here is the thing. The edge of the universe is not like the edge of a table or the shore of an ocean. You cannot walk up to it. You cannot touch it. In fact, if you tried to travel toward it, something very strange would happen. It would move away from you, always, forever, no matter how fast you went. Let me explain what I mean by that. And trust me, by the end of this journey, your sense of the cosmos will never be quite the same. To understand the edge of the universe, we first need to understand what we mean by the universe itself. When scientists talk about the universe, they are usually talking about everything that exists. All matter, all energy, all of space and time, every star, every planet, every galaxy, every particle of light, and every stretch of emptiness between them. That is the universe. But here is where things get interesting. There is a difference between the universe and the observable universe. The observable universe is the part we can actually see. It is the part where light has had enough time to travel to us since the beginning of time. Think of it like this. Imagine you are standing in the middle of a vast dark forest at night. You have a lantern, and you can only see as far as the light reaches. Beyond that circle of light, there might be more forest, probably is, but you cannot see it. You only know about the trees within your circle of visibility. The observable universe is our circle of visibility in the cosmos, and it has a definite size, about 93 billion light years across. Now that number might seem strange. If the universe is only about 13.8 billion years old, how can we see things 93 billion light years away? Should not the farthest light have only traveled 13.8 billion light years? This is where the strangeness begins. This is where the edge starts to reveal its true nature. You see, space itself is expanding, not just the stuff in space. Space itself. The fabric of reality is stretching, and it has been stretching since the very beginning. Imagine baking a loaf of raisin bread. You mix the dough, you add raisins throughout, and then you put it in the oven. As the bread rises, something interesting happens to those raisins. They all move apart from each other, not because the raisins themselves are moving through the dough, but because the dough between them is expanding. Now here is the key insight. From the perspective of any single raisin, it looks like all the other raisins are moving away, and the farther away a raisin is, the faster it seems to be receding. A raisin on the opposite side of the loaf is moving away much faster than a raisin right next door. This is not because distant raisins are moving faster through the dough. It is because there is more dough between them, and all that dough is expanding. The universe works the same way. We are like one of those raisins. Every distant galaxy is like another raisin, and the space between us, the cosmic dough, is constantly expanding. This is why distant galaxies appear to be rushing away from us, and the farther away they are, the faster they seem to be receding. This expansion has been happening since the Big Bang, about 13.8 billion years ago. But here is the mind-bending part. The expansion has been so significant that objects we can see today, objects whose light is just now reaching us, have actually moved much farther away during the time that light was traveling. When that light left its source, billions of years ago, the source was much closer to us. But while the light was making its journey, space kept expanding, pushing that source farther and farther away. So the observable universe is 93 billion light-years across, even though the universe is only 13.8 billion years old. The light we see from the most distant objects has been traveling for almost the entire history of the universe. But those objects have been carried away by the expansion of space during all that time. Right now, at the very edge of everything we can see, something impossible is happening. Light that has traveled for billions of years is finally reaching us, carrying secrets from the boundary of existence itself. And what it reveals is stranger than anything you could have imagined. The universe has an edge, but it is not a wall. It is not a barrier. It is something far more unsettling and far more beautiful. If you find yourself curious about what lies at the boundary of reality, consider subscribing and hitting that notification bell. You will want to join us as we venture deeper into these cosmic mysteries together. But what exactly is the edge of the universe? Is it a place you could travel to? A line drawn in the cosmic sand? Or is it something that defies our everyday understanding of what an edge even means? Here is the thing. The edge of the universe is not like the edge of a table or the shore of an ocean. You cannot walk up to it. You cannot touch it. In fact, if you tried to travel toward it, something very strange would happen. It would move away from you, always, forever, no matter how fast you went. Let me explain what I mean by that. And trust me, by the end of this journey, your sense of the cosmos will never be quite the same. To understand the edge of the universe, we first need to understand what we mean by the universe itself. When scientists talk about the universe, they are usually talking about everything that exists. All matter, all energy, all of space and time, every star, every planet, every galaxy, every particle of light, and every stretch of emptiness between them. That is the universe. But here is where things get interesting. There is a difference between the universe and the observable universe. The observable universe is the part we can actually see. It is the part where light has had enough time to travel to us since the beginning of time. Think of it like this. Imagine you are standing in the middle of a vast dark forest at night. You have a lantern, and you can only see as far as the light reaches. Beyond that circle of light, there might be more forest, probably is, but you cannot see it. You only know about the trees within your circle of visibility. The observable universe is our circle of visibility in the cosmos, and it has a definite size, about 93 billion light-years across. Now that number might seem strange. If the universe is only about 13.8 billion years old, how can we see things 93 billion light-years away? Should not the farthest light have only traveled 13.8 billion light-years? This is where the strangeness begins. This is where the edge starts to reveal its true nature. You see, space itself is expanding, not just the stuff in space. Space itself. The fabric of reality is stretching, and it has been stretching since the very beginning. Imagine baking a loaf of raisin bread. You mix the dough, you add raisins throughout, and then you put it in the oven. As the bread rises, something interesting happens to those raisins. They all move apart from each other, not because the raisins themselves are moving through the dough, but because the dough between them is expanding. Now, here is the key insight. From the perspective of any single raisin, it looks like all the other raisins are moving away, and the farther away a raisin is, the faster it seems to be receding. A raisin on the opposite side of the loaf is moving away much faster than a raisin right next door. This is not because distant raisins are moving faster through the dough. It is because there is more dough between them, and all that dough is expanding. The universe works the same way. We are like one of those raisins. Every distant galaxy is like another raisin, and the space between us, the cosmic dough, is constantly expanding. This is why distant galaxies appear to be rushing away from us, and the farther away they are, the faster they seem to be receding. This expansion has been happening since the Big Bang, about 13.8 billion years ago. But here is the mind-bending part. The expansion has been so significant that objects we can see today, objects whose light is just now reaching us, have actually moved much farther away during the time that light was traveling. When that light left its source billions of years ago, the source was much closer to us. But while the light was making its journey, space kept expanding, pushing that source farther and farther away. So the observable universe is 93 billion light-years across, even though the universe is only 13.8 billion years old. The light we see from the most distant objects has been traveling for almost the entire history of the universe, but those objects have been carried away by the expansion of space during all that time. This creates our cosmic horizon, the edge of the observable universe. It is not a physical barrier. It is the limit of visibility. Beyond this horizon, there is almost certainly more universe, more galaxies, more stars, more worlds. But their light has not had time to reach us yet. They are beyond our circle of lantern light in the cosmic forest. But wait, it gets stranger. Some of those distant objects are so far away, and the space between us is expanding so fast that their light will never reach us, ever. Think about that for a moment. There are places in the universe that we will never see, no matter how long we wait, no matter how powerful our telescopes become. They are forever beyond our reach. They exist, but they might as well be in a different universe entirely. This is because the expansion of space can happen faster than the speed of light. Now, before you object, this does not violate Einstein's theory of relativity. Relativity says that nothing can travel through space faster than light. But space itself is not traveling. Space is expanding. There is no speed limit on how fast space itself can stretch. And in the distant reaches of the cosmos, it is stretching so fast that light from those regions will never catch up to us. Imagine you are an ant on a rubber band. You are trying to walk from one end to the other, but someone is stretching the rubber band as you walk. If they stretch it slowly, you can still make progress. But if they stretch it fast, enough, you will never reach the other end, even if you walk forever. The new rubber band being created in front of you is more than what you can cover with your walking. Light in the distant universe is like that ant. Space is stretching so fast that light cannot make progress toward us. It is running on a cosmic treadmill, never getting any closer. This creates what scientists call the cosmic event horizon. It is different from the edge of the observable universe. The observable universe is everything whose light has had time to reach us so far. The cosmic event horizon is the boundary beyond which light will never reach us, no matter how long we wait. And here is the unsettling part. This horizon is not static. It is not fixed. Things are constantly slipping beyond it. Right now, as you listen to this, galaxies that were once visible to us, or would have been visible given enough time, are crossing that threshold. They are disappearing from our future forever. Their light will never arrive. Their stories will never be told to us. they are lost. But let us step back and appreciate what we can see, because what lies within our observable universe is already mind-boggling in its scale and beauty. If you could somehow see the entire observable universe at once, you would witness a cosmic web of unimaginable proportions. Billions of galaxies, each containing hundreds of billions of stars, arranged in vast filaments and clusters, separated by enormous voids of nearly empty space. It would look like a three-dimensional web of glowing threads, with dense knots where galaxy clusters gather, and dark bubbles where almost nothing exists. And at the very edge of our vision, at the limit of how far we can see, there is something remarkable. A faint glow that permeates the entire sky. It is called the cosmic microwave background, and it is the oldest light in the universe, the first light that was ever able to travel freely through space. To understand this ancient glow, we need to go back to the very beginning, back before there were stars or galaxies, back before there were even atoms as we know them. In the first moments after the Big Bang, the universe was unimaginably hot and dense. It was a seething soup of particles and radiation, so hot that atoms could not form. Electrons were too energetic to be captured by protons. Everything was a chaotic plasma, and importantly, this plasma was opaque. Light could not travel through it. Photons would only get so far before colliding with a free electron and scattering in a different direction. The universe was like a thick fog, and light was trapped within it. But the universe was expanding, and as it expanded, it cooled. About 380,000 years after the Big Bang, something magical happened. The universe cooled enough for electrons to finally be captured by protons, forming the first atoms, mostly hydrogen and helium. And when this happened, the fog cleared. Suddenly, light could travel freely. The universe became transparent. The light that was released at that moment, the first light to travel unimpeded through the cosmos, has been traveling ever since. For 13.8 billion years, those photons have been journeying through an ever-expanding universe. And now, ancient and stretched by the expansion of space, they reach our telescopes as a faint microwave glow. This is the cosmic microwave background. It is like a baby picture of the universe. A snapshot of what things looked like when the cosmos was only 380,000 years old. When you look at a map of this radiation, you are looking at the oldest thing it is possible to see. You are looking at the edge of visibility in time, not just in space. And what does this ancient light tell us? It tells us that the early universe was remarkably uniform, almost the same temperature everywhere. But not quite. There are tiny variations, fluctuations of only about 1 part in 100,000. These minuscule differences are the seeds of everything that exists today. Those slightly denser regions had slightly more gravitational pull. Over billions of years, they attracted more matter, grew larger, and eventually collapsed into the first stars and galaxies. Every star you see in the night sky, every galaxy in our telescopes, every planet and moon and asteroid, all of it traces back to those tiny ripples in the cosmic microwave background. Those faint variations at the edge of time are the ancestors of all structure in the universe. But here is something profound to consider. The cosmic microwave background is not the edge of the universe. It is the edge of what we can see. Beyond it, there is more universe. There was universe before that light was released, but we cannot see that far back. The fog is too thick. The wall of light is too bright. Everything before that moment is hidden from us. This brings us to one of the strangest aspects of the universe's edge. The edge is different depending on how you measure it. There is the edge of the observable universe, the most distant objects we can see. whose light has been traveling for almost 13.8 billion years. There is the cosmic microwave background, which represents the farthest back in time we can see using light. There is the cosmic event horizon, beyond which light will never reach us. And there is the actual edge of the universe, if such a thing even exists. Let us talk about that last one. Does the universe have an actual edge? A boundary where space simply ends? Most scientists believe the answer is no. The universe is probably either infinite or it curves back on itself. Let me explain both possibilities. First, the infinite universe. In this scenario, space just goes on forever in all directions. There is no edge because there is no end. No matter how far you travel, there is always more space ahead. The observable universe is just a tiny bubble within an infinite expanse. Beyond our horizon, there are more galaxies, more stars, more worlds, stretching out forever. This is actually the simplest possibility, mathematically speaking. The equations of general relativity work perfectly well with an infinite universe. And when we measure the shape of space, it appears to be flat, not curved. A flat universe is consistent with infinity, though it does not prove it. But there is another possibility. The universe might be finite but unbounded. This sounds like a contradiction, but it is not. Think of the surface of the Earth. The surface is finite. It has a definite area, but it has no edge. You can walk in any direction and never reach a boundary. You would just eventually come back to where you started. The universe might be like that, but in 3 dimensions instead of 2. Space might curve back on itself in a way that our 3-dimensional minds have trouble picturing. If you traveled far enough in a straight line, you might eventually return to your starting point. There would be no edge, but the universe would still be finite. We do not know which of these is true. The universe might be infinite. It might be finite but unbounded. Or there might be some other possibility we have not thought of. What we do know is that if the universe has an edge, a true boundary where space ends, we have found no evidence of it. And the idea raises troubling questions. If space ends somewhere, what is beyond it? What would the boundary be made of? These questions do not have good answers. So when we talk about the edge of the universe, we are usually talking about the edge of what we can observe, the horizon of visibility, not the edge of existence itself. But let us get back to that horizon, because it holds more surprises. Remember how space is expanding, and how the expansion is carrying distant galaxies away from us? Well, the expansion is not slowing down, it is speeding up. This was one of the most shocking discoveries in the history of cosmology. In the late 1990s, 2 teams of astronomers were trying to measure how quickly the expansion of the universe was slowing down. They expected to find that gravity, the attractive force between all the matter in the universe, was putting the brakes on the expansion. The universe was born in an explosive expansion, and it seemed natural that this expansion would gradually slow over time, like a ball thrown into the air slowing as it rises. But that is not what they found. Instead, they discovered that the expansion was accelerating. The universe was not slowing down. It was speeding up. More and more space was being created between galaxies with every passing moment, and the rate of creation was increasing. This was so unexpected, so contradictory to what scientists had assumed, that it required a new explanation. Something was pushing the universe apart. Something was overcoming the attractive force of gravity and driving the acceleration. Scientists name this mysterious something dark energy. Dark energy is one of the biggest mysteries in physics. We do not know what it is. We do not know where it comes from. We cannot detect it directly, We only know it exists because of its effect on the expansion of the universe. And it is not a small effect. Dark energy makes up about 68% of the total energy content of the universe. Most of the universe is made of something we do not understand. What we do know is this: dark energy has a peculiar property. Unlike matter and radiation, which become diluted as space expands, dark energy maintains a constant density. As the universe grows larger, the amount of dark energy grows with it. More space means more dark energy. This creates a runaway effect. The more the universe expands, the more dark energy there is to push it apart, which makes it expand faster, which creates more dark energy. It is cosmic acceleration with no end in sight. This has profound implications for the edge of our universe. As the expansion accelerates, our cosmic horizon is shrinking, not in the sense that we can see less, but in the sense that fewer and fewer things will ever be visible to us. Galaxies that are near the edge of our observable universe are being swept away. Their light will never reach us, and as time goes on, more and more of the universe will disappear from our view. In the far future, if you wait long enough, all other galaxies will have vanished from sight. The only galaxies left visible will be those in our local group, which are gravitationally bound together tightly enough to resist the expansion. The Milky Way, Andromeda, and a handful of smaller galaxies will merge into a single giant galaxy. And beyond that, there will be nothing visible. An infinite darkness in every direction. Imagine astronomers in that distant future, living in that merged supergalaxy. When they look out into space, they will see nothing but blackness, no distant galaxies, no cosmic web. They will have no evidence that the universe ever contained anything beyond their own island of stars. The cosmic microwave background will have stretched so far that it will be undetectable. The expansion will have erased all signs of its own history. Those future astronomers might conclude that their galaxy is all there is, that the universe is small and static and eternal. They would be wrong, but they would have no way of knowing it. The evidence of the true nature of the cosmos would be forever beyond their reach, carried away by the ever-accelerating expansion. We are living in a special time, a time when we can still see the evidence of the Big Bang, a time when distant galaxies are still visible, a time when the cosmic story is still readable in the sky. This window will not last forever. We are fortunate to exist in an era when the universe still reveals its secrets. But what lies beyond our horizon right now? What exists in the parts of the universe we cannot see? The most likely answer is more of the same. Beyond our observable universe, there are probably more galaxies, more stars, more worlds. The laws of physics are probably the same. The composition of matter is probably the same. It would be surprising if we lived in some special region where things were different. The principle of mediocrity suggests that our view is typical. What we see is representative of what exists everywhere. But we cannot be certain of this. Some theories suggest that the universe might be different in regions far beyond our horizon. Perhaps the laws of physics themselves could vary from place to place. Perhaps there are regions where matter behaves differently, where different particles exist, where the fundamental constants have different values. We have no way of knowing. And then there is an even stranger possibility, the multiverse. Some versions of cosmological theory suggest that our universe might be just one of many. Perhaps an infinite number of universes, each with its own properties, each with its own history, each separated from the others by more than just space. In this picture, what we call the universe is just one bubble in an endless foam of universes. Our observable horizon is not just the limit of our sight within our universe. It is also the boundary of our entire universe within a larger multiverse. Beyond that boundary might lie not just more space, but entirely different realms with different physics, different dimensions, different everything. This is highly speculative. We have no direct evidence for the multiverse. It may be untestable in principle, but it is consistent with some of our best theories about how the cosmos works, particularly the theory of cosmic inflation. Inflation is the idea that in the first tiny fraction of a second after the Big Bang, the universe underwent an enormous expansion. Not the gradual expansion we see today, but an explosive growth that stretched a region smaller than an atom to larger than the entire observable universe in far less than a blink of an eye. If inflation happened once, it might have happened many times, in many places, creating many universes. Our universe might be one of countless bubbles that nucleated out of an eternally inflating background. Each bubble is a universe. Each has its own Big Bang. Each expands and evolves independently, and the spaces between them are growing so fast that they can never interact. This is the strangest possible version of the edge, an edge that is not just a horizon of visibility, but a boundary between fundamentally different realities, between different versions of existence itself. We may never know if this is true. The multiverse might be forever beyond our ability to test. But it is humbling to consider that the edge we can see, the limit of our observable universe, might be only the beginning of a much deeper boundary, a boundary between everything we can ever know and an infinity of things we cannot. Let us come back down to earth for a moment, or rather, let us come back to our observable universe and appreciate what we do know about its edge. The edge of the observable universe is approximately 46.5 billion light-years away in every direction. That is the current distance to the cosmic microwave background, the farthest thing we can see. Light from that distance has been traveling for almost the entire history of the universe, and during that time, the expansion of space has carried it far beyond where it started. At this edge, we are seeing the universe as it was about 380,000 years after the Big Bang. Before that, the universe was opaque. We cannot see further back in time using light, but we can see the conditions that existed at that boundary. We can see the tiny fluctuations in temperature that would become the seeds of galaxies. We can see the uniform glow of a young cosmos just beginning its journey. Beyond the cosmic microwave background, there is more universe. The universe did not begin at the surface of last scattering. There was universe before that moment. There was the hot plasma era before atoms formed. There was the era of nucleosynthesis, when protons and neutrons fused into the first atomic nuclei. There was the electroweak era and the quark era, and moments of physics we barely understand. All of this happened before the cosmic microwave background, and all of it is hidden from us. But we can infer what happened during those early times. We can use the laws of physics to work backwards. We can use particle accelerators to recreate some of those conditions on tiny scales. We can piece together the story of the early universe from the clues left behind. The edge of visibility is not the edge of knowledge, and there is another kind of edge we have not discussed yet, the edge in time. The universe had a beginning. About 13.8 billion years ago, everything we see today was compressed into an incredibly hot, dense state. This was the Big Bang. Not an explosion in space, but an explosion of space. The beginning of space and time themselves. This is another kind of edge. Not an edge in space, but an edge in time. Before the Big Bang, as far as we can tell, there was no before. Time itself began with the Big Bang. Asking what happened before the Big Bang might be like asking what is north of the North Pole. The question might not make sense. This is deeply strange to our everyday intuition. We are used to thinking of time as a river that flows forever in both directions. But according to our best current theories, time had a beginning. The past is not infinite. There is an edge to history. Now, some theories suggest ways around this. Some suggest that the Big Bang was not the absolute beginning, but rather a transition from some earlier state. Perhaps our universe emerged from the collapse of a previous universe. Perhaps it bubbled out of an eternal inflating background. Perhaps time did exist before the Big Bang, just in a form we do not understand. These ideas are speculative and largely untestable, but they remind us that our understanding of the temporal edge is incomplete. What we can say is that the observable universe has two kinds of edges: an edge in space, the cosmic horizon beyond which light can't reach us, and an edge in time, the Big Bang before which we cannot see, and perhaps before which time itself did not exist. These edges define the boundaries of our cosmic existence. Everything we know, everything we can ever discover, lies within these bounds. But within these bounds, there is so much. Consider the numbers. The observable universe contains roughly 2 trillion galaxies. That is 2,000 billion. Each galaxy contains on average about 100 billion stars. So the total number of stars in the observable universe is something like 200 sextillion. That is a 2 followed by 23 zeros. More stars than grains of sand on all the beaches of Earth. More stars than seconds since the beginning of time. And many of those stars have planets. Conservative estimates suggest there are more planets than stars. Perhaps 10 times more. Perhaps 100 times more if you count all the moons and dwarf planets and rogue worlds drifting between stars. The observable universe is overflowing with worlds. On how many of those worlds does life exist? We do not know. We have only confirmed life on one planet so far, ours. But the numbers suggest that life should be common. With so many worlds, so many chances, it seems unlikely that we are alone. Yet we have found no definitive evidence of life elsewhere. This is the great question that looms over everything. Are we alone in this vast cosmos? Is life common or rare? Are there other minds out there looking at their own night sky, wondering about their own cosmic edge? If there are, they are seeing the same edge we are. The same cosmic microwave background, the same horizon of visibility. From their perspective, they are at the center of their own observable universe, just as we are at the center of ours. And the strange thing is, both perspectives are correct. There is no center of the universe. Every point is the center of its own observable sphere. This is one of the most counterintuitive aspects of cosmology. We are at the center of the observable universe, but so is everyone else. The astronomer on a planet in a distant galaxy is also at the center of their observable universe. Their horizon is different from ours. They can see things we cannot see, and we can see things they cannot see. But both of us are equally central. The universe has no preferred location, no special point, no absolute center. This principle, the cosmological principle, says that the universe is homogeneous and isotropic on large scales. Homogeneous means the same everywhere. Isotropic means the same in all directions. No matter where you are or which way you look, the universe appears roughly the same. This is not true on small scales, of course. Your living room is different from deep space, but on scales of hundreds of millions of light years, the universe smooths out into a uniform distribution. This uniformity is itself remarkable and somewhat mysterious. Why should the universe be so smooth? The cosmic microwave background, that ancient light from the edge of visibility, shows that the early universe was even smoother. Temperatures were the same to within 1 part in 100,000 across regions that could never have been in contact with each other. How did these separated regions know to have the same temperature? This is called the horizon problem, and it was one of the motivations for the theory of inflation. If the universe underwent a brief period of rapid expansion very early on, then regions that are now widely separated could have once been in close contact. They could have reached the same temperature before being pushed apart by inflation. This solves the horizon problem and explains the remarkable uniformity we observe. But it also means that the edge of the observable universe is a relic of this early expansion. The horizon we see today is shaped by events that happened in the first tiny fraction of a second. The edge of our vision was determined before atoms existed, before stars existed, before anything we would recognize as familiar. Let us pause for a moment and take in the full picture. You are lying here, perhaps in bed, perhaps on a couch, listening to these words. And as you listen, ancient photons from the edge of time are passing through you. The cosmic microwave background is everywhere. It fills all of space. Right now, in this moment, light that has been traveling since the universe was young is arriving at your location. You are bathed in the oldest light in existence, and most of those photons will pass right through you without interaction. They will continue their journey, traveling onward into space, perhaps to reach some distant telescope someday, perhaps to travel forever into the expanding void. You are a brief way station on a journey that began billions of years ago. This is the reality of living in a universe with edges in space and edges in time. We exist within a finite bubble of visibility, surrounded by an infinity we cannot access. We exist at a particular moment in cosmic history, with a past we cannot visit and a future we cannot see. We are bounded creatures in a bounded view of an unbounded whole. And yet, from within these bounds, we have learned so much. We have mapped the cosmic microwave background with extraordinary precision. We have measured the expansion rate of the universe. We have discovered dark energy and dark matter. We have counted galaxies and calculated the age of the cosmos. We have pieced together the story of the universe from its first moments to the present day. All of this from one small planet orbiting one ordinary star in one typical galaxy among trillions. The edge of the universe is strange, but so is the fact that beings like us can contemplate it, that atoms can arrange themselves into creatures that wonder about the nature of existence, that the universe has produced observers capable of observing it, of measuring its edges, of asking what lies beyond. This might be the strangest thing of all, not the edge itself, but the fact that we are here to think about it. Now let us venture deeper into the mysteries that lurk at the cosmic edge. Let us explore what the boundary of our universe tells us about the nature of reality itself. We have talked about the observable universe and its horizon. We have talked about the cosmic microwave background and the oldest light. We have talked about the expansion of space and the strange acceleration driving it. But there is more to explore, much more. Consider the Hubble sphere. This is another kind of boundary, different from the ones we have discussed. The Hubble sphere is the distance at which the expansion of space equals the speed of light. Beyond the Hubble sphere, space is expanding away from us faster than light can travel toward us. Now you might think this is the same as the cosmic event horizon, but it is not quite. The Hubble sphere is defined by the current expansion rate. The cosmic event horizon takes into account how the expansion rate will change in the future. Because the expansion is accelerating, these two boundaries are different. Here is the confusing part. Light from beyond the Hubble sphere can still reach us under certain circumstances. If a photon is just beyond the Hubble sphere, it is being carried away by expansion faster than it is moving toward us. But if the expansion rate decreases in the future, even slightly, the photon might eventually make it. The expansion could slow down enough that the photon starts making progress, eventually overcoming the recession and reaching our telescopes. This has actually happened. Some of the most distant objects we have observed are beyond the current Hubble sphere. Their light was emitted when they were even farther beyond it. But as the universe evolved and the expansion rate changed, those photons were able to make it to us. They crossed the Hubble boundary and arrived at Earth billions of years after they were emitted. However, the cosmic event horizon is different. It takes into account the full future of expansion. With dark energy causing acceleration, objects beyond the cosmic event horizon will never reach us, no matter how long we wait. The expansion will never slow down enough. Those photons are lost forever. This creates a strange situation. Some objects that are currently beyond the Hubble sphere might still be visible to us in the future if their photons were emitted long ago. But objects that are currently beyond the cosmic event horizon will never be visible, even though they might be closer than some things we can already see. The geometry of an expanding universe is not intuitive. Let me give you another way to think about this. Imagine space as an infinite conveyor belt moving away from you. Light is like a person walking on the conveyor belt toward you. If the belt is moving slowly, the person can walk faster than the belt and eventually reach you. If the belt speeds up, the person might still reach you if they got a head start. But if the belt accelerates forever, eventually, even a person who is relatively close will never make it. The belt keeps speeding up until no one can overcome it. The cosmic event horizon is where the belt is moving so fast and will continue to accelerate so much that nothing beyond it will ever reach you. It is the point of no return for light itself. And this horizon is shrinking, or rather, the amount of the universe that will ever be visible to us is shrinking. More and more galaxies are crossing the cosmic event horizon every moment. Once they cross, they are gone forever. Their light will never arrive. We will never see them again. This is happening right now as you listen. Galaxies are disappearing, not exploding or disintegrating, just slipping silently beyond the edge of what we can ever observe. It is a quiet catastrophe, an invisible loss, a slow deletion of the cosmos from our potential knowledge. In about 100 billion years, give or take, all galaxies outside our local group will have vanished from view. The sky will be dark except for our own merged supergalaxy. The rest of the universe will still exist, presumably, but it will be as if it does not. No light, no information, no connection, a universe of one. This is one of the more melancholy implications of an accelerating expansion. The cosmos is not just big, it is also lonely, and it is getting lonelier. But let us not dwell too long in cosmic melancholy. There is wonder to be found in the edge as well. Let us talk about what we have learned from studying the boundary of the observable universe. The cosmic microwave background, that ancient glow from the edge of time, has been one of the most important tools in cosmology. By studying it in exquisite detail, we have learned profound truths about the nature of reality. First, we learned that the universe is flat. When we say flat, we do not mean two-dimensional. We mean that the geometry of space is Euclidean. Parallel lines remain parallel forever. The angles of a triangle add up to exactly 180 degrees. Space is not curved like the surface of a sphere or a saddle. It is flat like an infinite plane. This flatness has implications. A flat universe is consistent with being infinite in extent. It also requires a very precise balance between the density of the universe and the expansion rate. Too much density, and the universe would curve in on itself and eventually collapse. Too little, and it would curve outward and expand forever without ever forming structures like galaxies. The universe is balanced on a knife edge of flatness, and this balance is one of the clues that led to the theory of inflation. Second, we learned the composition of the universe. The cosmic microwave background tells us that ordinary matter, the atoms that make up everything we can see and touch, accounts for only about 5% of the total energy content of the universe. Dark matter makes up about 27%. Dark energy makes up about 68%. We live in a universe dominated by things we do not understand. Dark matter is invisible. It does not emit light or interact with light. We know it exists because of its gravitational effects. It holds galaxies together and shapes the large-scale structure of the cosmos. Without dark matter, galaxies would fly apart. Stars would not form. We would not exist. And yet we have never detected a dark matter particle directly. We do not know what it is made of. Dark energy is even more mysterious. It is not a substance in the usual sense. It is a property of space itself, a tendency for empty space to push apart. It counteracts gravity on the larger scales. It drives the acceleration of the expansion, and we have no idea why it exists or what determines its strength. The cosmic microwave background, that faint glow from the edge of our vision, told us that we are profoundly ignorant about the nature of reality. 95% of the universe is made of things we cannot see and do not understand. The edge reveals our limitations as much as it reveals the cosmos. But this is not cause for despair. It is cause for excitement. There is so much more to learn. So many mysteries waiting to be solved. The edge of our knowledge is not a wall. It is a frontier. Third, we learned about the seeds of structure. The tiny fluctuations in the cosmic microwave background, those 1 part in 100,000 variations in temperature, are the origin of everything. Galaxies, stars, planets, you and me. All of it traces back to those primordial ripples. These fluctuations are thought to have originated from quantum mechanics. In the first instance of the universe, quantum fluctuations, the inherent uncertainty in the fabric of reality, created tiny variations in density. Inflation then stretched these microscopic variations to cosmic scales. What started as subatomic randomness became the blueprint for the entire structure of the universe. Think about that. The distribution of galaxies across the observable universe, the voids and filaments and clusters, all of it was determined by quantum events in the first fraction of a second. The arrangement of matter on the largest scales reflects the smallest scales. The edge of the very big is connected to the edge of the very small. This is one of the deepest insights from studying the cosmic edge. The universe is a quantum object, not just in its smallest components, but in its larger structures. The randomness that governs subatomic particles has shaped the cosmos itself. Let us now turn to the future. We have talked about what the edge of the universe looks like today and what it looked like in the past. But what will it look like in the future? How will the edge evolve as time goes on? The answer depends on what happens to dark energy. If dark energy remains constant, as it appears to be doing now, the expansion will continue to accelerate forever. The cosmic event horizon will continue to shrink. More and more of the universe will slip beyond our reach. Eventually, all distant galaxies will be gone. The observable universe will consist only of our local group. And then, as stars die and are not replaced, even that will fade to darkness. This is the heat death scenario. The universe slowly winds down. Energy spreads out and becomes unusable. Stars burn out. Black holes evaporate. Matter decays. The cosmos approaches a state of maximum entropy, where nothing interesting can happen anymore. An eternity of cold, dark, empty nothing. But there are other possibilities. Some theories suggest that dark energy might not be constant. It might change over time. If it increases, the acceleration could become so severe that it tears apart not just galaxies, but stars, planets, atoms, and eventually space itself. This is called the Big Rip. The expansion becomes so violent that nothing can hold together. The fabric of reality is shredded. The Big Rip would be spectacular and terrifying, a cosmic apocalypse that destroys everything. Fortunately, current evidence suggests that dark energy is not increasing in this way. The Big Rip is not our most likely future. But we cannot rule it out entirely. There is another possibility, though it seems less likely given what we know. If dark energy decreases or turns negative, the expansion could slow down and eventually reverse. Gravity would take over. The universe would begin to contract. Everything would fall back together faster and faster, until all matter and energy was compressed into an incredibly hot, dense state, a mirror image of the Big Bang. This is called the Big Crunch. Some theories suggest that a Big Crunch could trigger a new Big Bang. A new universe could be born from the ashes of the old. This is the Big Bounce scenario. The universe oscillates forever between expansion and contraction, Big Bang and Big Crunch, an eternal cosmic heartbeat. It is a poetic idea, death and rebirth on the largest possible scale. But current evidence suggests the expansion is accelerating, not slowing. We do not appear to be heading for a big crunch. The cosmos seems destined for eternal expansion, not cyclic rebirth. So what does all this mean for the edge of the universe? In the most likely scenario, the edge will continue to recede. More and more of the cosmos will disappear from view. Our observable universe will shrink in terms of what we can ever access, even as it continues to expand in terms of physical size. We will become ever more isolated, ever more alone, until eventually we are trapped in a small island of dead stars surrounded by an infinite darkness. That is the long-term forecast. Hundreds of billions of years from now, trillions of years. Timescales so vast that human life is less than a blink. We will not be around to see it. Our species, if it survives, will have transformed into something unrecognizable long before the last stars burn out. But the edge of the universe affects us now too. It shapes our understanding of who we are and where we fit in the cosmic story. We are creatures of the edge. We live on the thin surface of a small planet, at the edge between rock and sky. We exist at a particular moment in cosmic history, at the edge between the fiery birth of the universe and its cold, dark death. We see out to the edge of the observable cosmos, the boundary between what we can know and what we cannot. Edges define us, boundaries shape us. The limits of the universe are also the limits of our possible experience. And yet, within those limits, we have found so much. Beauty and complexity and wonder, love and art and science, the ability to ask questions and seek answers, the capacity to imagine what lies beyond even what we can ever see. The universe may be stranger than we can imagine, but we can still imagine. And in that imagination, we touch something beyond the edge. Let us continue our exploration. There are still more wonders waiting at the boundary of everything. We have discussed the large-scale structure of the universe, the cosmic web of galaxies and voids. But let us look more closely at this structure and what it tells us about the edge. When we map the distribution of galaxies in the observable universe, we see a pattern. Galaxies are not scattered randomly. They are arranged in a web-like structure. Filaments of galaxies connect dense clusters surrounding vast empty regions called voids. It looks like soap bubbles, or the neural network of a brain, or the veins in a leaf. This cosmic web is the largest structure in the universe. The filaments can stretch for hundreds of millions of light years. The voids can be equally vast. Some voids are so empty that they contain almost nothing. A few stray galaxies drifting through an ocean of emptiness. These are the loneliest places in the universe. At the intersections of filaments, where multiple strands come together, we find galaxy clusters. These are the densest regions of the cosmic web. Thousands of galaxies bound together by gravity, embedded in enormous halos of dark matter. Galaxy clusters are the most massive gravitationally bound objects in existence. The cosmic web formed over billions of years, shaped by gravity acting on those initial fluctuations in the cosmic microwave background. The slightly denser regions attracted more matter, grew larger, and collapsed into filaments and clusters. The slightly less dense regions became voids, growing emptier as matter flowed away toward the denser areas. It is structure formation in action, written across the sky. When we look at the edge of the observable universe, we are looking at this web as it existed billions of years ago. Light from the most distant galaxies shows us the early cosmos, when the web was just beginning to form. We can see the infant structures that would grow into the massive filaments and clusters of today. This is one of the remarkable aspects of looking into space. We see not just across distance, but back through time. The farther we look, the younger the universe appears. At the edge of the observable universe, we see the universe as a child. The cosmic microwave background shows us the universe as an infant. The light tells us a story of growth and change. But there is a puzzle here. The universe looks roughly the same in all directions. The cosmic web, on large scales, is isotropic. There is no preferred direction, no special region. This is what we expect from the cosmological principle. But why? How did regions that have never been in contact, that are on opposite sides of our observable universe, end up looking so similar? This is the horizon problem again. And again, inflation provides a potential answer. Before inflation, all the regions that would become our observable universe were in close contact. They reached a uniform state through normal physical processes. Then inflation stretched them apart, carrying them beyond the horizon of causal contact, but preserving their similarity. The uniformity we see at the edge is a relic of contact that happened before the universe became so vast. Inflation makes predictions that we can test. It predicts certain patterns in the cosmic microwave background. It predicts the spectrum of those primordial fluctuations. And so far, the predictions match the observations remarkably well. This gives us confidence that something like inflation really happened. The edge of the observable universe carries signatures of events that occurred when the universe was far smaller than an atom. Let us talk about another aspect of the edge. The edge is not fixed. It is growing. Every second, light from more distant objects reaches us for the first time. Photons that have been traveling since the early universe finally arrive at our telescopes. The edge of the observable universe is constantly expanding, as light from farther away completes its journey. But remember, this expansion of the visible edge is fighting against the expansion of space itself. New objects are coming into view, but old objects are disappearing beyond the cosmic event horizon. In the current era, these two effects roughly balance. We can still see most of what we will ever see. But in the future, the cosmic event horizon will win. The accelerating expansion will overwhelm the steady inflow of ancient light. Our view will shrink. So we are living in a golden age of observational cosmology, a time when the edge of the visible universe is about as large as it will ever be, a time when the evidence of the Big Bang is still detectable, a time when we can see billions of galaxies and piece together the story of the cosmos. Future civilizations will not be so lucky. If intelligent beings arise billions of years from now, they will look out at a much smaller, much emptier sky. The cosmic microwave background will have faded to undetectability. The distant galaxies will be gone. The evidence of the true nature and history of the universe will be erased. We are cosmologically privileged, not because we are at a special place in space, but because we are at a special place in time. The universe has given us a window, and that window will eventually close. This realization brings a certain urgency to our scientific endeavors. We should learn as much as we can while we can. We should map the cosmos in detail. We should measure the cosmic microwave background with ever greater precision. We should count galaxies and measure their distances and understand their properties. The information is available now. It will not always be. Future generations may inherit only the data we collect. The observations we make today could be the only record of the true universe that survives into the distant future. We are the witnesses of a cosmic era that will never come again. Let us shift our attention to some of the specific objects at the edge of our vision. What have our telescopes revealed about the most distant reaches of the observable universe? The farthest galaxies we have observed are seen as they were about 400 million years after the Big Bang. This was during what is called the cosmic dawn, the era when the first stars and galaxies were forming. The universe was transitioning from darkness to light. Before the first stars, the universe was dark. The cosmic microwave background had been emitted, but there were no stars to shine. The cosmos was filled with hydrogen and helium gas, slowly falling together under the pull of gravity, but not yet condensed into luminous structures. This was the cosmic dark ages. Then, about 100 to 200 million years after the Big Bang, the first stars ignited. These primordial stars were different from stars today. They formed from pure hydrogen and helium, with no heavier elements. They were probably very massive and very hot, shining with intense ultraviolet light. They did not last long. They burned through their fuel quickly and exploded as supernovae, seeding the universe with the first heavy elements. These first-generation stars also began to ionize the surrounding gas. Their ultraviolet radiation stripped electrons from hydrogen atoms, creating bubbles of ionized gas around each star. As more stars formed, these bubbles grew and merged. Eventually, the entire universe became ionized. This process is called reionization, and it marks the end of the Dark Ages and the beginning of the era of galaxies. The most distant galaxies we have found are from this era. They are faint, small, and irregular, just beginning to form. Glimpses of the cosmic dawn from the edge of what we can see. Each new discovery pushes our view a little closer to the Big Bang, a little closer to the absolute edge of visibility. The James Webb Space Telescope has been revolutionary in this regard. Its infrared vision can pierce the veil of cosmic dust and see the stretched, reddened light of these ancient galaxies. It has found galaxies at record-breaking distances, galaxies that existed when the universe was less than 5% of its current age. These discoveries are rewriting our understanding of how galaxies form and evolve. But even the James Webb Space Telescope has limits. It cannot see all the way to the cosmic microwave background with its galaxy surveys. The earliest light from stars is still separated from the CMB by hundreds of millions of years. There is a gap in our observations, a dark age that we are only beginning to probe. Future observatories may fill in this gap. Telescopes designed to detect the faint radio signals from hydrogen gas in the dark ages. Gravitational wave detectors that could sense the ripples from the earliest cosmic events. New ways of seeing that go beyond electromagnetic light altogether. The edge of the observable universe is not the edge of what we can learn. Let us talk about one more type of edge, the edge of physics itself. Our understanding of the universe is based on theories. General relativity describes gravity and the large-scale structure of space-time. Quantum mechanics describes the behavior of particles at the smallest scales. Together, they form the foundation of modern physics. But these theories break down at the edge. At the moment of the Big Bang, when the entire observable universe was compressed into an infinitely small point, both theories fail. General relativity predicts infinite densities and curvatures. Quantum mechanics cannot handle such extreme conditions. We need a new theory, a quantum theory of gravity, to understand what happened at the very beginning. We do not have such a theory yet. String theory and loop quantum gravity are candidates, but neither is complete or fully tested. The edge of the universe in time, the moment of the Big Bang, is also the edge of our physics. We do not know how to describe it. Similarly, at the edge of black holes, in the singularities, at their centers, our theories break down. The event horizon of a black hole is another kind of cosmic edge, a boundary beyond which nothing can return. What happens inside a black hole? What is the nature of the singularity? These questions remain unanswered because our theories cannot penetrate to those extremes. The edge of the universe teaches us humility. It shows us the limits of our knowledge. It reminds us that there is more to reality than what we currently understand. The strangeness at the boundary is not just about distance or time. It is about the boundaries of human comprehension itself. And yet, we keep pushing. We build better telescopes. We develop new theories. We test ideas against observations. We expand the edge of what we know, even as the cosmic edge reminds us how much remains unknown. This is the human story. A species that evolved on one small planet, looked up at the sky, and dared to ask what lies at the edge of everything. A species that built instruments to see billions of light years into space and billions of years into the past. A species that uncovered the cosmic microwave background, discovered dark energy, and mapped the large-scale structure of the universe. We are small. The universe is vast, but our minds can encompass it. Our thoughts can reach the edge. Our understanding can touch the boundaries of existence. That is not nothing. That is something remarkable. So as we continue this journey through the edge of the universe, remember that you are part of this story. You are made of atoms forged in stars. You are a way for the universe to know itself. You are contemplating the edge of everything. And in doing so, you are participating in one of the most profound activities that matter and energy have ever engaged in. The universe is stranger than you can imagine, but you can still try to imagine it. And in that trying, You join a tradition that stretches back to the first humans who looked up at the stars and wondered what was out there. The tradition of questioning, the tradition of seeking, the tradition of pushing beyond the edges we know toward the edges we do not. Let us keep pushing. Now we turn to perhaps the most mind-bending aspect of the cosmic edge. What actually happens at the boundary of the observable universe? What would you experience if you could somehow travel there? First, let us be clear. You cannot travel to the edge of the observable universe. It is too far away and receding too fast. Even traveling at the speed of light, you would never reach it. The expansion of space would carry it away faster than you could approach. It is a horizon in the truest sense, always receding, never reachable. But let us imagine anyway. Let us engage in a thought experiment. Suppose you had a magical spacecraft that could instantly transport you to the current location of an object at the edge of our observable universe. What would you find? You would find more universe, more galaxies, more stars, more space. There would be nothing special about that location. No wall, no boundary, no marker saying you have reached the edge. From your new vantage point, you would have your own observable universe, your own cosmic horizon. And Earth, your home, would now be near the edge of your view. Objects that were beyond your horizon before would now be visible. Objects that were visible before would now be beyond your horizon. The edge is relative. It depends on where you are. Everyone has their own cosmic horizon. Your edge is not my edge. And no edge is special. This is deeply counterintuitive. We are used to thinking of edges as absolute. The edge of a table is the edge of that table, period. But the edge of the observable universe is observer dependent. It exists only from a particular perspective. From a cosmic perspective, there is no edge at all, just an infinite, or at least very large expanse of space and matter and energy. Now let us think about what happens at the horizon itself. Not the location in space, but the boundary as seen from Earth. What is happening at that boundary? The light from objects at the edge of our observable universe is extremely redshifted. As light travels through expanding space, it gets stretched. Its wavelength increases. Blue light becomes red. Red light becomes infrared. Infrared becomes microwave. The farther the light has traveled, the more it has been stretched. At the edge of the observable universe, this redshift is enormous. Light that started as ultraviolet has been stretched to microwave wavelengths. Light that started as blue has been stretched beyond visibility entirely. The most distant objects in our telescopes are seen in wavelengths far longer than the light they originally emitted. Time is also affected, because the universe was expanding while the light was traveling, and because expansion has slowed and accelerated at different rates. The relationship between distance and time is complex. When we look at a galaxy near the edge, we are seeing it as it was billions of years ago. But the light travel time is not the same as the current distance. The galaxy has moved much farther away since the light was emitted. This creates an illusion. It looks like distant objects are moving away from us at enormous speeds. Some appear to be receding faster than light. But this is not actual motion through space. It is the expansion of space itself. The galaxy is not flying away. The space between us is growing. At the cosmic horizon, this recession velocity exceeds the speed of light. Objects beyond the cosmic event horizon are receding so fast that light from them will never reach us. But they are not moving through space faster than light. Relativity is not violated. Space is just expanding so rapidly that light cannot keep up. This is one of the most common misconceptions about the universe. People hear that distant galaxies are moving away faster than light, and think this violates Einstein. It does not. Nothing is moving through space faster than light. Space itself is expanding. There is no speed limit on the expansion of space. Let me try another analogy. Imagine an infinitely long rubber band stretched along a table. An ant is walking along the rubber band toward you. The ant can only walk at a certain maximum speed, like light can only travel at the speed of light. Now imagine you are stretching the rubber band while the ant walks. If you stretch slowly, the ant can still make progress. It might take longer to reach you, but it will eventually arrive. But if you stretch fast enough, the ant will never make progress. The new rubber band appearing between you and the ant will always be more than the ant can cover by walking. The ant is walking toward you at its maximum speed, but it is getting farther away because the rubber band is stretching so fast. The ant is not violating any speed limit. It is walking as fast as it can, but it cannot beat the stretching of the rubber band. Light at the cosmic horizon is like that ant. It is traveling at the cosmic speed limit, but it cannot overcome the expansion of space. Now, something interesting happens at the edge. As objects approach the cosmic horizon, their light becomes more and more stretched. Their time appears to slow down. If you could watch an object falling toward the cosmic horizon, it would seem to slow to a standstill and freeze forever at the edge, never quite crossing, its light growing ever fainter and redder. This is reminiscent of what happens at the event horizon of a black hole. An object falling into a black hole, as seen from outside, appears to slow and freeze at the horizon, never quite crossing. The light grows redder and dimmer. The analogy is not perfect, but it is suggestive. Both are horizons beyond which information cannot reach us. Both are boundaries where strange things happen to light and time. But there is a key difference. The event horizon of a black hole is a true one-way boundary. If you fall into a black hole, you cannot get out. The cosmic event horizon is observer-dependent. If you travel to a galaxy near our cosmic horizon, from your new location, you would have a different horizon. Our galaxy might be near your horizon, but you would not be trapped. You would just have a different view. The cosmic horizon is not a physical barrier. It is a limit of causal contact, a boundary beyond which we cannot send signals and from which we cannot receive signals. But it is not the same for everyone. It is a perspective, not a place. Let us now consider what all this means for the question of whether we are alone in the universe. If there are other intelligent beings out there, at the edge of our observable universe, what are the implications? An alien civilization on a planet near the edge of our observable universe would be incredibly distant in time as well as space. We would be seeing their light from billions of years ago. By now, that civilization might have risen and fallen, evolved and transformed 1,000 times over. We would know nothing of their current state. We would see only their ancient past, and they would see only our ancient past. If they looked toward us, they would see the Milky Way as it was billions of years ago. Perhaps they would not see Earth at all. Perhaps our solar system did not exist yet when their light began its journey. We would be mutual observers of each other's prehistory. Communication would be impossible in any practical sense. Even if we sent a signal at the speed of light, it would take billions of years to arrive. And by the time it did, the expansion of the universe might have carried them beyond the cosmic event horizon. The reply would never reach us. This is the cosmic loneliness imposed by the edge of the universe. Other beings might exist, but they are separated from us not just by space but by time and causality. The universe is big enough that we might never be alone in the sense of being the only intelligence. but we might be effectively alone in the sense of being unable to communicate with or even detect other minds. Some scientists have speculated about whether there could be ways around this. Could information travel faster than light through some unknown mechanism? Could wormholes connect distant parts of the universe? Could some exotic physics allow communication across the cosmic horizon? We do not know of any such mechanisms. General relativity allows for wormholes in principle, but we have no idea how to create them or stabilize them. Faster than light travel appears to be forbidden by the fundamental structure of space-time. For now, the cosmic edge is a real barrier to contact, but perhaps that is okay. Perhaps the vastness and isolation are part of what makes our existence special. We are rare and precious, at least from our perspective. The cosmic edge defines a realm within which we have meaning, within which our actions matter, within which our consciousness has purchase on reality. Beyond the edge, there might be more minds, more civilizations, more meaning, but we cannot reach them, and they cannot reach us. Our bubble of visibility is our domain. The edge is our boundary, and within that boundary, we are the ones who observe, who question, who seek to understand. That is not a small thing. In a universe of edges and horizons, of limits and boundaries, the act of contemplating the edge is itself an achievement. We are the universe knowing its own limits. We are matter reflecting on its own extent. We are the edge becoming conscious of itself. Let us continue deeper into the strangeness at the edge. We have covered much ground, but there is still so much more to explore. The universe keeps revealing new layers of mystery the closer we look at its boundaries. Consider the nature of time at the cosmic scale. We have talked about looking back in time by looking far away. But what does time even mean at the edge of the universe? Time, according to Einstein's relativity, is not absolute. It flows at different rates depending on your motion and your location in a gravitational field. Near a black hole, time slows dramatically. For a fast-moving particle, time passes differently than for a stationary observer. The simple, steady tick of a clock is an illusion. Time is flexible, bendable, stretchable. At cosmic scales, this flexibility becomes profound. The universe has an age, about 13.8 billion years since the Big Bang. But this age is measured in a specific reference frame, the rest frame of the cosmic microwave background. It is the age as measured by a clock that is at rest with respect to the average motion of matter in the universe. If you are moving very fast relative to this cosmic rest frame, or if you were deep in the gravitational well of a massive object, your clock would tell a different story. Your universe would have a different age. The past and future would be shifted relative to what others observe. At the edge of the observable universe, time has behaved differently than it has here. The expansion of space affects the flow of time. A clock at the edge, in the early universe, was running differently than a clock here now. The comparison is not even straightforward, because what does it mean to compare clocks that are separated by billions of light years and billions of years? This is one of the subtleties of cosmology. We talk about the age of the universe as if it were a simple number, but time is more complicated than that. The age depends on who is asking and from where. The edge of the universe is not just far away in space. It is in a different temporal context altogether. Let me give you an example. Suppose there was an observer at the location of the cosmic microwave background, about 380,000 years after the Big Bang. From their perspective, the universe was young. Only a few 100,000 years had passed. But from our perspective, looking at them from across billions of years of cosmic expansion, They are ancient. The light from their moment has been traveling for almost the entire history of the universe. Who is right? Both are. Time is relative. The edge of the universe is both ancient and young, depending on perspective. This relativity of time has implications for the question of what is happening at the edge right now. There is no universal now. Einstein showed that simultaneity is relative. What is happening now at a distant location depends on your motion. Different observers will disagree about what is simultaneous with this moment. So when we ask what is happening at the edge of the observable universe right now, we are asking a question that does not have a well-defined answer. Right now is local. The edge is far. The concepts do not map onto each other cleanly. This might seem like philosophical nitpicking, but it matters for understanding what the edge really is. The edge is not a static boundary sitting out there at a fixed location, waiting for us to observe it. The edge is a dynamic, relative, observer-dependent phenomenon. It is as much about us, the observers, as it is about the cosmos out there. The universe has no center and no edge in any absolute sense. Every point is equivalent to every other point. Every observer sees their own horizon. The edge we perceive is our edge, not the edge. It is a product of the speed of light, the age of the universe, and the expansion of space filtered through our particular vantage point. Understanding this relativity is key to truly grasping the strangeness at the cosmic boundary. The edge is not a place. It is a perspective. It is a limit of knowledge, not a limit of existence. Now let us explore some of the more exotic possibilities for what might lie beyond the edge. We have touched on the multiverse idea, but let us dig deeper. The multiverse concept comes in several varieties. The simplest is the level 1 multiverse, which is just the idea that the universe extends infinitely beyond our cosmic horizon. In an infinite universe, every possible configuration of matter will occur somewhere. There would be regions identical to our observable universe, with copies of Earth and copies of you, an infinite number of each. The edge of our horizon is just where our view ends, not where reality ends. This is not as crazy as it sounds. If the universe is truly infinite and homogeneous, then statistically, every possible arrangement must repeat eventually. The odds of any particular configuration are tiny, but infinity is big enough to contain anything that is possible. Of course, we have no way of knowing if the universe is actually infinite. It might be finite but much larger than our observable patch. It might have unusual topology that makes the question meaningless. But if it is infinite, then the level 1 multiverse is a straightforward consequence. The level 2 multiverse is more exotic. This is the idea that comes from eternal inflation, the notion that inflation never completely ended everywhere. In this picture, our observable universe is one bubble in a vast, endlessly inflating background. Other bubbles nucleate and grow, each becoming a universe with its own properties. The bubbles are separated by inflating space that expands faster than they can grow. They will never touch. They will never communicate. In the level 2 multiverse, different bubbles might have different laws of physics. The fundamental constants might vary. The number of dimensions might differ. What we think of as the laws of nature might be just local bylaws specific to our bubble. Other bubbles might have different particles, different forces, different mathematics describing their behavior. This is highly speculative. We cannot test it directly. Signals from other bubbles cannot reach us. But it is consistent with some versions of inflation and string theory. The edge of our observable universe, in this view, is not just a horizon of visibility. It is a boundary between fundamentally different realities. There are even stranger levels of multiverse proposed by physicists and philosophers. The level 3 multiverse comes from quantum mechanics, the many worlds interpretation. In this view, every quantum measurement causes the universe to split into branches, one for each possible outcome. The branches do not interact after they split. Each goes its own way, creating an ever-branching tree of realities. In the many worlds interpretation, there is not just one universe with one history. There are countless universes, countless histories, all existing simultaneously in some sense. The edge is not just spatial or temporal. It is a boundary in possibility space. And the level 4 multiverse is the most extreme. This is the idea that any mathematically consistent structure is a universe somewhere. Every possible set of laws, every possible geometry, every possible logic, if it can be described mathematically, it exists. Reality is not a specific thing. Reality is everything that could be. These ideas go far beyond what we can test or observe. They are more philosophy than science, at least for now. But they illustrate how rich and strange the question of the cosmic edge can become. When we ask what lies beyond the edge of the universe, we might be asking about more than just more space. We might be asking about the limits of existence itself. Let us bring things back closer to home. Not all the strangeness is at the far edge. Some of it is right here, in how we interact with and perceive the edge. When you look at the night sky, you are seeing the edge in a sense. You are seeing light that has traveled across space and time to reach your eyes. Some of that light is from nearby, just a few light years away. Some is from across the galaxy. Some is from other galaxies millions of light years distant. And if you had the right instruments, you could see all the way to the cosmic microwave background. Every photon that reaches you is a messenger from the past, a record of something that happened long ago and far away. You are constantly receiving information from the edge all the time. The edge is not out there. It is here, encoded in the light that surrounds you. The cosmic microwave background is the most distant message we receive, but it is also everywhere. It fills the sky uniformly. It fills this room. It passes through you constantly. Billions of photons from the edge of time are streaming through your body right now, every second. You are embedded in the edge. You are bathed in its light. The boundary of the observable universe is not distant and remote. It is intimate and present. The edge is here. This is one of the beauties of cosmology. The most distant and ancient parts of the universe are immediately accessible to us. We do not have to travel to study them. They come to us, carried by light that has been traveling since the dawn of time. We sit at the center of a vast sphere of ancient light, and that light speaks to us of the edge. Consider what it means to see the cosmic microwave background. You are seeing light that was emitted when the universe was only 380,000 years old. Light that has traveled for 13.8 billion years. Light that has stretched by a factor of over 1,000. You are seeing a time before stars, before galaxies, before planets, before life. You are seeing the edge of history. And this light is not just out there somewhere. It is here. It is the static on an old television set. It is a small fraction of the noise your radio picks up. It is photons passing through your walls, your furniture, your body. The edge is not abstract. It is physical, tangible, present. This intimate presence of the cosmic edge is one of the wonders of our universe. The vastness is not separate from us. It is part of our immediate environment. We live at the center of a sphere of ancient light that tells the story of cosmic history. The edge is our neighbor. Now let us talk about what all this edge talk means for the future of science and exploration. We are living in a golden age of cosmology, as I mentioned before. Our telescopes can see almost to the limit of what light can reveal. Our theories can describe the universe from a fraction of a second after the Big Bang to billions of years into the future. We have measured the composition of the cosmos, mapped the cosmic web, detected gravitational waves from merging black holes. The achievements are stunning, but there is so much more to learn. The edge still holds secrets. One frontier is the dark ages of the universe, the era between the cosmic microwave background and the first stars. We cannot see this era with light, because there were no sources of light, but we might be able to probe it with other means. Radio telescopes could detect the signal from hydrogen gas in the dark ages. Gravitational wave detectors could sense ripples from the earliest cosmic events. New windows on the universe might reveal what was happening at the edge of time when no stars yet shone. Another frontier is dark matter. We know it exists from its gravitational effects, but we do not know what it is. The edge of the observable universe provides clues. The cosmic microwave background carries information about dark matter's role in the early universe. The large-scale structure of the cosmic web is shaped by dark matter. Perhaps by studying the edge more carefully, we can uncover the nature of this mysterious substance. And dark energy remains deeply puzzling. Why does the expansion accelerate? What is the cosmological constant, if that is what dark energy is? Or is dark energy something more complex, changing over time, varying from place to place? The edge is where dark energy's effects are most dramatic. The cosmic horizon is shaped by dark energy. Understanding one requires understanding the other. The edge of our knowledge is as important as the edge of the universe. Every unknown is an opportunity. Every mystery is an invitation. The cosmos beckons us to keep exploring, keep questioning, keep pushing the boundaries of understanding. Future telescopes will see farther and clearer. Future theories will describe deeper and more. Future generations will know things we cannot imagine. The edge will recede, not the physical edge, but the edge of our ignorance. And as it does, new mysteries will appear. There is always another edge to explore. This is the nature of science. It is not about reaching a final truth. It is about the endless journey toward the edge. Every answer reveals new questions. Every discovery opens new horizons. The edge is not a destination. It is a direction. Let us now bring our exploration back to you, the listener. What does the edge of the universe mean for your life, here and now, on this small planet? It might seem like cosmic edges are irrelevant to daily existence. The observable universe is incomprehensibly vast. The cosmic microwave background is incomprehensibly old. What does any of this have to do with your morning coffee, or your relationships, or your hopes and dreams? And yet, I think it matters. I think contemplating the edge changes something in us. It provides perspective. It induces humility. It inspires wonder. When you understand that you are one tiny observer in one brief moment of cosmic history, looking out at a universe of trillions of galaxies, seeing light that has traveled for billions of years, it shifts something in your priorities. The petty concerns fade a little. The larger questions come into focus. What matters? What is meaningful? What do we want to do with our brief time in this vast cosmos? The edge of the universe reminds us that we are part of something immense. We are not isolated individuals floating in a void. We are connected to the whole. The atoms in your body were forged in stars. The patterns in your brain are shaped by the same physics that shape the cosmic web. The light hitting your eyes comes from across the breadth of space and time. You are a node in the cosmic web, a point where the universe has become conscious of itself, a place where matter and energy have organized into something that can ask questions about edges and boundaries and meaning. This is remarkable. This is precious. This is worth celebrating. The edge of the universe is stranger than you can imagine. But so are you, a collection of atoms that somehow wonders about the cosmos. A brief pattern of complexity that contemplates eternity. A creature of the edge, living on the thin surface of a small world, reaching out with mind and instruments to touch the boundaries of everything. You are the universe experiencing itself. You are stardust become conscious. You are the edge looking at the edge. Let us continue our journey and explore some more specific phenomena at the cosmic boundary. We have talked about the cosmic microwave background at length, but there are other relics of the early universe that tell us about the edge of time. One of these is the cosmic neutrino background. Neutrinos are ghostly particles that barely interact with matter. Trillions of them pass through your body every second without any effect. In the early universe, neutrinos were produced in vast quantities and then decoupled from other matter even earlier than light did. The cosmic neutrino background was released about 1 second after the Big Bang, compared to 380,000 years for the cosmic microwave background. If we could detect the cosmic neutrino background, we could see even further back in time than the CMB allows. We could get a picture of the universe when it was only a second old. Unfortunately, neutrinos are incredibly difficult to detect. Their energies are so low and their interactions so weak that current technology cannot see them. But future experiments might. The cosmic neutrino background is a frontier at the edge of time, waiting to be explored. Even earlier, there should be a cosmic gravitational wave background. Gravitational waves are ripples in space-time caused by accelerating masses. The early universe was full of violent events that would have produced gravitational waves, from phase transitions to inflation itself. These primordial gravitational waves would carry information from the first instance of existence, from times we cannot probe with light or even neutrinos. We have already detected gravitational waves from merging black holes and neutron stars, but the primordial background is much fainter. It is mixed with the foreground noise of more recent cosmic activity. Separating it out will require advanced detectors and sophisticated analysis, but if we succeed, we will have a window into the very beginning, a way to see the edge of time itself. There is even speculation about what might lie at the true edge, the moment of the Big Bang, the initial singularity. Our current theories break down there. We need a quantum theory of gravity to describe it, but some physicists have speculated that the singularity might not be an edge at all. It might be a transition from some earlier state. Perhaps the Big Bang was a quantum fluctuation in a pre-existing vacuum. Perhaps it was the rebirth of a universe that had previously collapsed. Perhaps time and space themselves emerged from something more fundamental. These ideas push us to the very edge of physics. They ask what it means for existence to have a beginning. They challenge our notions of time and causality. They take us to the boundary of what we can think, not just what we can see. The edge of the universe is not just spatial. It is temporal. It is physical. It is conceptual. It is the limit of our models and our minds, and it is always inviting us to go further. Now let us explore the practical implications of living in a universe with edges. The cosmic horizon has consequences for what we can ever know and ever do. It sets fundamental limits on information and communication. No signal can travel faster than light, and the expansion of space further limits what we can reach. If we want to send a message to a galaxy near the edge of the observable universe, the message would take billions of years to arrive. By the time it got there, if it ever could, the recipient would have moved even further away. Communication across the cosmos is practically impossible on human timescales. Even within our galaxy, the distances are vast. The nearest star system, Alpha Centauri, is about 4 light-years away. A message would take 4 years to arrive and another 4 years for a reply to come back. An interstellar conversation would be agonizingly slow. The edge of the observable universe makes the cosmos feel lonely. We are separated from potential neighbors by distances that make meaningful contact impossible. Even if there are billions of civilizations out there, we might never know about most of them. They are too far, too old, too removed from our causal sphere. But this loneliness has a flip side. It means we have room. We have privacy. We have the opportunity to develop and grow without interference. The vastness that isolates us also protects us. We are free to make our own way in a quiet corner of the cosmos, and within our corner, there is plenty to explore. The Milky Way alone contains hundreds of billions of stars. Even if we never leave our galaxy, there is enough to keep us busy for millions of years. The edge of the observable universe is not the edge of opportunity. It is just the far boundary of a realm that is already unimaginably rich. The edge also has implications for the long-term future of civilization. If humanity, or our descendants, survives long enough, we will face the shrinking cosmic horizon. More and more of the universe will disappear from view. Eventually, only the local group of galaxies will be visible. This has led some thinkers to contemplate cosmic-scale projects. Could we somehow gather information from the edge before it disappears? Could we send probes to distant galaxies while they are still reachable? Could we preserve knowledge of the true cosmos for future generations who will never be able to see it? These are speculative questions about timescales far beyond human planning. But they illustrate how the edge shapes our cosmic destiny. We are not just passive observers of the edge. We are active participants in a universe that is evolving and changing. The edge constrains what we can do, but it also motivates us to do what we can while we can. Let me now tell you about some of the specific numbers that define the edge, the quantitative details of the cosmic boundary. The observable universe has a diameter of about 93 billion light-years. This is the current distance from one edge to the opposite edge, accounting for the expansion of space since the light was emitted. The cosmic microwave background has a redshift of about 1,100. This means the wavelength of its light has been stretched by a factor of over 1,000 since it was emitted. What started as visible light is now microwave radiation. The most distant galaxy we have observed has a redshift of about 14. This means its light has been stretched by a factor of 15. We are seeing it as it was about 300 million years after the Big Bang. The Hubble constant, which measures the current expansion rate, is about 70 kilometers per second per megaparsec. This means that for every megaparsec of distance, about 3.3 million light-years, objects appear to be moving away at an additional 70 kilometers per second. At the edge of the observable universe, this recession velocity exceeds the speed of light. The cosmic event horizon is currently about 16 billion light-years away. Objects beyond this distance will never be visible to us, no matter how long we wait. This distance is shrinking in the sense that fewer objects will ever be visible in the future. The age of the universe is about 13.8 billion years. This is the time since the Big Bang in the cosmic rest frame. In our local frame, moving through the universe, the age is very close to the same. These numbers define the edge. They set the scale of our cosmic existence. They tell us how big, how old, how fast. They are the coordinates of our place in the cosmos. But numbers alone do not capture the wonder. The edge is not just a set of measurements. It is an experience, a feeling of vastness and mystery, a confrontation with the limits of existence. You can know the numbers and still be amazed by what they mean. Let us explore one more aspect of the edge before we begin to draw conclusions. The philosophical implications of living in a universe with horizons. The existence of the cosmic horizon challenges our intuitions about reality. We tend to think of reality as what exists. What is there? What is true? But the cosmic horizon introduces a fundamental uncertainty. We cannot know what lies beyond it. We can infer, we can speculate, we can theorize, but we cannot observe, we cannot verify. This has led some philosophers to question whether what lies beyond the horizon is even real in any meaningful sense. If we can never observe it, never interact with it, never receive any information from it, does it exist? Is existence the same as observability? Or can things exist beyond the reach of any possible observation? Most physicists would say that yes, things exist beyond the horizon. The laws of physics do not care about our ability to observe. The universe extends beyond what we can see. But the philosophical question remains interesting. The edge forces us to think about what existence means and what knowledge requires. There is also the question of what the edge tells us about our significance. On one hand, we are tiny and brief, occupying a minuscule fraction of the observable universe for a minuscule fraction of cosmic time. The edge reminds us of our smallness, our transience, our cosmic insignificance. On the other hand, we are the ones asking the questions. We are the part of the universe that has become aware of the edge. We have built instruments that see to the edge of time. We have developed theories that explain the edge of space. In the entire vastness of the cosmos, we are among the rare configurations of matter that know about the vastness. This is a kind of significance, even if it is not the significance of being large or central. The edge teaches humility and pride simultaneously. Humility before the immensity of existence. Pride in our ability to comprehend even a fraction of it. Both are appropriate responses. And now we approach the climax of our journey, the moment where all these threads come together, the place where the strangeness of the edge reaches its peak. Let me paint a picture for you, a picture of the universe at its most extreme. Imagine you could somehow see the entire observable universe at once. Not just a slice, not just a map, but the whole thing. All 93 billion light years of it, spread out before your mind's eye. You would see a sphere of light, a bubble of visibility centered on wherever you happen to be. At the center, things look relatively normal. Galaxies going about their business, stars burning, planets orbiting, the familiar cosmos. But as you look farther out, toward the edge, things change. The galaxies become younger. You are looking back in time. The familiar shapes dissolve into smaller, more chaotic structures. The primordial ancestors of the great galaxies you see nearby. Farther still, and the galaxies disappear entirely. You are now looking at the cosmic dawn, the era before most stars existed. Faint glimmers of light from the very first stellar generations. A universe still waking up from its dark ages. And then, at the very edge, the wall of light, the cosmic microwave background, a glowing surface surrounding everything in every direction. This is the edge of time made visible, the boundary beyond which the universe was opaque, the last scattering surface, where photons finally broke free and began their long journey toward your eyes. Beyond this wall, there is more universe, but you cannot see it, not with light. The wall is the limit of visibility, the edge of the picture. Everything we know about the cosmos is contained within this sphere, surrounded by that ancient glow. Now imagine something else. Imagine you could watch time pass on cosmic scales. Imagine speeding up your perception so that millions of years pass like seconds. You would see the edge moving, not the physical boundary, but the horizon of visibility. Light from more distant objects would arrive, pushing the edge farther out. The observable universe would grow, encompassing more and more of existence. But you would also see the cosmic event, horizon shrinking. Galaxies at the edge would begin to fade, their light redshifting beyond detection, their images stretching into infinity as they cross the threshold of no return. One by one, distant galaxies would disappear, not destroyed, just removed from the realm of the observable, lost to the accelerating expansion. Over billions of years, you would watch the sky empty. The cosmic web would thin. The background glow of distant galaxies would fade. Eventually, only the local group would remain, Andromeda, approaching and merging with the Milky Way. A handful of smaller galaxies gravitationally bound to us, everything else gone. And then, over trillions of years, even the stars in this merged supergalaxy would burn out. Red dwarfs, the longest-lived stars, would exhaust their fuel. White dwarfs would cool to invisibility. Neutron stars would spin down. Black holes would slowly evaporate through Hawking radiation. The last structures in the universe would dissolve into a thin mist of cold particles drifting through an ever-expanding void. This is the ultimate fate of the universe, according to our best current understanding. Heat death, the final equilibrium where nothing interesting can happen anymore, an eternity of darkness and cold, stretching out forever. The edge of the universe, pushed to its ultimate conclusion, is an edge of existence itself, a boundary between being and non-being. The cosmos will not end with a bang, but with the slow dimming of the last lights, the gradual fading of the last warmth, the quiet settling into eternal stillness. This is the fate that the edge points toward. The accelerating expansion that defines our cosmic horizon also defines our cosmic destiny. The same physics that hides most of the universe from our view will eventually hide everything from everything. The edge will swallow all. But wait, before you despair, let me offer a different perspective. Let me clear the air of this cosmic dread and show you something wonderful. Yes, the universe will end in darkness. Yes, the edge will consume everything. Yes, in the unfathomably distant future, all the light will be gone, and nothing will remain but cold, empty space expanding forever. But that future is unimaginably far away, trillions of years, timescales that make the entire current age of the universe look like a blink. We are not at the end. We are at the beginning. Right now, stars are being born. In stellar nurseries across the Milky Way and in galaxies throughout the cosmos, clouds of gas are collapsing under their own gravity, igniting nuclear fusion, blazing into brilliant new suns. The universe is still in its creative phase. The era of star formation has barely begun compared to how long it could theoretically continue. Right now, planets are forming around those new stars. Worlds are taking shape. In some of those worlds, conditions might be right for life. The universe is still producing the conditions for complexity, for biology, for minds. Right now, on at least one planet that we know of, Intelligent beings are contemplating the cosmos. They are building telescopes to see the edge. They are developing theories to explain the edge. They are asking questions about the edge that no one has ever asked before. Consciousness exists. The universe has awakened to its own existence. This is the miracle of now. In the vast sweep of cosmic time, we happen to exist during the one era when the universe is alive with light and activity. We are not at the beginning or the end. We are in the brief flowering, the cosmic spring, the time of creation. The edge of the universe is strange, but it is also beautiful. It frames a cosmos that is bursting with energy and possibility. The fact that there is an edge means that there is something inside it, and what is inside it is magnificent. Let us sit with this for a moment. The wonder of existence, the privilege of consciousness, the beauty of a universe that has edges and horizons and limits, but within those limits contain stars and galaxies and worlds and life and thought. You are part of this. You are one of the points where the universe knows itself. Your consciousness is one of the places where the edge is contemplated, where the vastness is measured, where the mystery is felt. You matter, not despite the cosmic scale, but because of it. In all that vastness, you are among the rare arrangements of matter that can appreciate the vastness. The edge does not diminish you, it elevates you. It shows the context in which your existence is remarkable. Against the backdrop of heat, death, and eternal darkness, your brief flickering of awareness is precious beyond measure. You are a light in the cosmic night, a moment of warmth before the cold, a thought in the silence, and you are not alone. There are billions of other humans having their own experiences, asking their own questions, feeling their own wonder. There might be trillions of other beings throughout the cosmos doing the same. We are a community of consciousness scattered across an immense universe, all of us looking at our own edges, all of us wondering what lies beyond. This is the resolution to the strangeness at the edge. Not that the strangeness goes away, but that we can hold it in our minds alongside the beauty. The universe is strange. It is also wonderful. The edge is terrifying in its implications. It is also awe-inspiring in its grandeur. Both are true. Both can be felt simultaneously. Let us now begin to draw our journey to a close. We have traveled far together, from the hook that caught your attention, through the body that explored the depths, to the climax that escalated the wonder, and now to the resolution that brings peace. What have we learned? Let me summarize. The edge of the universe is not a wall or a barrier. It is a horizon of visibility, the limit of how far light has been able to travel since the beginning of time. Beyond this horizon, there is almost certainly more universe, but we cannot see it. Space itself is expanding, and this expansion is accelerating. The accelerating expansion creates a cosmic event horizon, beyond which light will never reach us. More and more of the universe is disappearing from view, slipping beyond this horizon forever. The cosmic microwave background is the oldest light we can see, released when the universe was only 380,000 years old. It marks the edge of visibility in time, the wall beyond which the universe was opaque. The universe is probably either infinite or finite, but unbounded. Either way, it has no edge in the sense of a boundary where space ends. The edge we perceive is a limit of our view, not a limit of existence. Dark energy and dark matter dominate the cosmos, making up about 95% of its total content. We do not understand what they are. The edge of our knowledge is as real as the edge of our vision. The far future holds heat death, the slow fading of all structures and activity into eternal cold darkness. But that future is unimaginably distant, and we live in a time of cosmic flourishing. We are cosmically privileged to exist in an era when the evidence of the Big Bang is still visible, when distant galaxies still light up the sky, when the story of the universe is still readable. This window will not last, will, forever, and we are remarkable for being able to contemplate any of this. Conscious beings who can measure cosmic horizons and theorize about what lies beyond, the universe knowing itself through us. This is what the edge of the universe tells us. We are small but significant, brief but meaningful, limited but capable of reaching toward the limitless. The edge defines us, and we define the edge. We are, in a sense, where the edge becomes aware. As we prepare to end this journey, I want to leave you with a feeling. Not just facts and figures, but an emotional sense of what the edge means. Close your eyes, if it is safe to do so. Imagine yourself lying under a dark sky, far from city lights. Above you, stars, thousands of them scattered across the darkness. Each one a sun, some of them orbited by planets, all of them part of our galaxy. Now imagine zooming out. The stars become a river of light, the Milky Way seen from outside. 100 billion suns spinning in a great pinwheel. Our sun is one of them, unremarkable, ordinary, precious. Zoom out further. The galaxy becomes a point of light among millions of others, the local group, then the Virgo supercluster, then the observable universe, a cosmic web of filaments and voids, clusters and superclusters stretching in all directions. And at the edge of this view, the glow, the cosmic microwave background, the oldest light, the boundary of the visible. Beyond it, more universe, forever beyond reach. You are at the center of all this, not because you are special in a cosmic sense, but because everyone is at the center of their own observable universe. The horizon surrounds you equally in all directions. You are the middle of your own cosmic sphere, and from that center, you can look out to the edge. You can contemplate the vastness. You can feel the wonder and the strangeness and the beauty. You can be, for this moment, a point where the universe experiences itself. The edge is out there, 93 billion light years across, and the edge is in here, in your mind as you imagine it. The two are connected. The cosmos and the consciousness that contemplates it are not separate. They are one. This is the deepest truth at the edge of the universe, that there is no real separation between the observer and the observed. You are made of the same atoms that make up the galaxies. The same physics that governs the cosmic microwave background governs the firing of your neurons. The edge you contemplate is contemplating itself through you. Strange, yes, stranger than you could have imagined, almost certainly, but also beautiful, also meaningful, also true. And that wraps up our journey to the edge of the universe. What an incredible voyage it has been, from the cosmic horizon to the cosmic microwave background, from dark energy to dark matter, from the far future to this precious present moment. The universe's edge is stranger than we could have imagined at the start. Horizons that are not walls, but perspectives. Expansion that accelerates without visible cause. Edges in time as well as space. A fate of darkness waiting in the distant future, but a present of wonder and discovery. If this journey left you with a sense of awe, if it shifted your perspective on your place in the cosmos, if it gave you something to think about as you drift off to sleep tonight, I am glad. That was the goal, to share the wonder that comes from contemplating the edge of everything. Hit that like button if you found value in this exploration. Subscribe to the channel if you want to continue these cosmic journeys together. We have so much more to discover, from black holes to exoplanets, from the Big Bang to the fate of stars. Each topic is a new edge to explore. Drop a comment below and let me know what aspect of the universe's edge fascinated you most. Was it the cosmic microwave background, that ancient glow from the dawn of time? Was it the accelerating expansion and the galaxy slipping away forever? Was it the philosophical implications of living in a bounded view of an unbounded whole? I would love to hear your thoughts. The universe is vast and our time within it is brief. But while we are here, we can look up, we can wonder, we can reach with our minds toward the edge of everything. And in that reaching, we become part of the cosmic story. Thank you for joining me on this journey. Sleep well tonight, knowing that you are cradled in the heart of an immense and beautiful cosmos, surrounded by ancient light, held by the mystery, part of the edge itself. Until next time, keep looking up, keep wondering, keep exploring the edges of everything. The universe has so many more secrets to share. Good night. The cosmic microwave background surrounds you still. Photons from the edge of time pass through your walls, your roof, your body. The oldest light in existence, arriving constantly, everywhere, telling the story of the beginning. And tomorrow, when you wake, the universe will still be there. The edge will still be receding. The stars will still be burning. The story will continue. You are part of that story. A brief chapter in an endless book, but every chapter matters. Every moment of consciousness is a universe knowing itself. Rest now. Dream of galaxies and horizons. Dream of light traveling through the void. Dream of the edge, strange and beautiful, holding all of existence within its embrace. The universe is stranger than you can imagine, and you are part of that strangeness, part of that beauty, part of the edge. Sleep well. But before you close your eyes completely, let me share a few more thoughts, a few more wonders from the edge that we did not have time to fully explore. Think about this. The light from the cosmic microwave background is the oldest light we can see, but it is not the oldest thing in the universe. Before light could travel freely, there were other things, other relics that might still be out there. We talked briefly about the cosmic neutrino background, but let me tell you more about what this means. Neutrinos decoupled from matter about 1 second after the Big Bang. For comparison, light decoupled about 380,000 years after, so the neutrino background is about 380,000 times older than the oldest light. If we could detect it, we would be seeing the universe as it was just 1 second old, 1 second after the beginning of everything. The universe was still a seething plasma of quarks and gluons, rapidly cooling and condensing into protons and neutrons. The fundamental building blocks of matter were just forming, and neutrinos were streaming away, carrying information about that primordial moment. Those neutrinos are still out there. The cosmic neutrino background fills all of space, just like the cosmic microwave background. But neutrinos are incredibly difficult to detect. They pass through ordinary matter like it is not there. A neutrino could travel through a light year of solid lead and have only a 50% chance of interacting with anything. Detecting the cosmic neutrino background requires technology we do not yet possess, but we are working on it. Scientists are developing new detectors, new techniques, new ways of sensing these ghostly particles. Someday, perhaps within the next century, we might be able to see the cosmic neutrino background. And when we do, we will have pushed the edge back further than ever before, from 380,000 years to 1 second, a journey of 400,000-fold into the past. And even that is not the ultimate edge. Before the neutrinos decoupled, there were gravitational waves. ripples in space-time created by the violent dynamics of the early universe. These gravitational waves were produced in the first tiny fractions of a second, during inflation, and perhaps even before. The primordial gravitational wave background would carry information from times so early that even neutrinos cannot reach. We are talking about the first trillionth of a trillionth of a trillionth of a second. Times when the universe was smaller than an atom. Times when physics, as we know, it was just coming into being. Detecting these primordial gravitational waves is one of the holy grails of cosmology. We have indirect evidence that they exist, from patterns in the cosmic microwave background. But direct detection would be transformative. It would let us see the edge of time in a completely new way, not with light, not with matter, but with the very fabric of space-time itself. This is the future of edge exploration. New messengers from the cosmic boundary, neutrinos, gravitational waves, and perhaps things we have not even imagined yet. Each new window reveals a different aspect of the edge. Each new detection pushes our knowledge further back toward the beginning. Let me also tell you about some of the strangest objects that live near the edge of our observable universe. The most distant things we have ever seen. There are quasars at the edge. Quasars are incredibly luminous objects powered by supermassive black holes devouring matter at the centers of young galaxies. They shine so brightly that we can see them across almost the entire observable universe. Some quasars are so distant that their light has been traveling for more than 13 billion years. When we look at these distant quasars, we are seeing black holes that formed when the universe was less than 1 billion years old. This is remarkable. It means that supermassive black holes, containing millions or billions of times the mass of our Sun, formed very quickly after the Big Bang. We do not fully understand how this happened. It is one of the puzzles that the edge presents to us. There are also gamma ray bursts at the edge. Gamma ray bursts are the most violent explosions in the universe, releasing more energy in seconds than our Sun will emit in its entire lifetime. Some are caused by collapsing massive stars, others by merging neutron stars. They are so bright that we can detect them from almost anywhere in the observable universe. The most distant gamma ray burst ever detected occurred about 13.1 billion years ago. For a brief moment, a dying star at the edge of the observable universe outshone everything else in the sky. A beacon from the cosmic dawn signaling across almost the entire history of the universe. These objects at the edge are not just curiosities. They are probes. They let us study the conditions at the cosmic boundary. The light from a distant quasar passes through billions of light years of intervening space, and it picks up signatures of everything it encounters along the way. Gas clouds, galaxies, the cosmic web itself. By analyzing the light from edge objects, we can map the universe between here and there. This technique is called absorption spectroscopy. The light from a distant source acts like a flashlight, illuminating everything between the source and us. We can see shadows where gas blocks the light. We can measure the composition and temperature and motion of material at vast distances. The edge objects become tools for understanding the middle. Let me also expand on something we touched on earlier. The question of whether we are alone. The observable universe contains roughly 2 trillion galaxies. Each galaxy contains on average about 100 billion stars. Most of those stars probably have planets. The numbers are staggering. Even if the odds of life arising on any given planet are incredibly small, the sheer number of opportunities suggests that life should be common. And yet, we have found no definitive evidence of life beyond Earth. No signals from alien civilizations. No artifacts in our solar system. No evidence in the cosmic microwave background of engineering on a galactic scale. The universe appears to be silent. This is sometimes called the Fermi paradox, after the physicist Enrico Fermi, who supposedly asked, "Where is everybody? If life is common and civilizations arise frequently, why do we not see evidence of them everywhere?" The edge of the universe bears on this question in several ways. First, the vastness of space and time means that even if civilizations are common, they might be separated by such enormous distances that contact is impossible. We talked about this earlier. The cosmic horizon is a real barrier to communication. Second, the edge in time matters. Civilizations might arise and fall on timescales much shorter than cosmic timescales. A civilization that existed 1 billion years ago might have flourished and perished long before our solar system even formed. A civilization that will exist 1 billion years from now might arise long after humanity is gone. The window for contact is narrow. Third, the accelerating expansion means that the situation is getting worse, not better. More and more of the universe is slipping beyond the cosmic event horizon. Potential neighbors are being carried away forever. The isolation imposed by the edge is deepening with time. But here is another way to think about it. The edge makes whatever life does exist more precious. In a universe where contact is difficult or impossible, where civilizations might be separated by unbridgeable gulfs of space and time, each instance of life is a miracle. Each mind is a treasure. The silence of the cosmos is not a verdict on life's rarity so much as a testament to life's preciousness. We might be one of countless civilizations scattered across an infinite universe, all of us looking at our own edges, all of us wondering if we are alone, unable to communicate, unable to confirm each other's existence, but all of us part of the same cosmic story. The edge separates us physically, but unites us conceptually. We are all creatures of the horizon. Let me share one more idea before we truly conclude. The idea that contemplating the edge changes us. When you think about the cosmic horizon, when you really sit with the scale and the strangeness, something shifts in your perspective. The problems that seem so large become smaller. The worries that consumed you become more manageable. The petty concerns of daily life fade in the light of cosmic immensity. This is not escapism. It is perspective. The edge does not make your problems disappear, but it does put them in context. It reminds you that you are part of something much larger than yourself. It connects you to the sweep of cosmic history. It grounds you in a story that began billions of years before you were born and will continue billions of years after you are gone. There is comfort in this. A kind of cosmic comfort that comes from knowing your place. You are small, yes. Brief, yes. But you are also essential. You are one of the nodes where the universe becomes conscious. You are one of the points where the edge is known. And there is motivation in this too. If our time is brief, then it matters what we do with it. If the window of cosmic visibility is closing, then it matters that we learn what we can while we can. If we are among the rare arrangements of matter that can appreciate the cosmos, then appreciation becomes a kind of duty, a responsibility to the universe that made us. The edge of the universe is an invitation to wonder, to explore, to understand, an invitation to be fully present in this cosmic moment, an invitation to embrace both the strangeness and the beauty. You have accepted that invitation by listening this far. You have traveled to the edge and back. You have contemplated horizons and horizons beyond horizons. You have let the immensity wash over you. Now carry that with you. Let the perspective stay. When you encounter difficulties tomorrow, Remember the cosmic microwave background. When you feel small and insignificant, remember that smallness is what makes significance possible. When you wonder what it all means, remember that you are part of what gives it meaning. The edge of the universe is stranger than you can imagine, but you have imagined it, at least in part. You have touched the boundary with your mind. You have been, for this time, a creature of the cosmic horizon. That is no small thing. That is everything. The night deepens around you. The stars wheel overhead, though you might not see them from where you are. The cosmic microwave background continues its endless reign of ancient photons. The universe expands, moment by moment, carrying galaxies toward the edge and beyond. And you are here, present, aware, part of it all. Rest well. The edge will be there tomorrow, waiting to be contemplated again. The cosmos will continue its story, and you will continue yours within it. Sleep now. Dream of light traveling through the void. Dream of horizons receding into infinity. Dream of a universe strange and beautiful beyond imagination. And know that you are home. The cosmos is your home. The edge is your boundary. And within that boundary, you belong. Good night, fellow traveler. Until we meet again at the edge of everything. There is one more thing I want to share with you before this journey truly ends. A thought experiment that captures the essence of what the edge means. Imagine you could send a message into the future. A message that would survive for billions of years and be received by whatever intelligent beings exist then. What would you tell them about the universe? You would want to tell them about the galaxies, the trillions of galaxies that fill our sky, arranged in that magnificent cosmic web. You would want to describe the great clusters and the vast voids, the filaments of light stretching across hundreds of millions of light years, the sheer abundance of structure and beauty. But here is the heartbreaking part. They might not believe you. Remember what we said about the far future. The accelerating expansion will carry all distant galaxies beyond the cosmic event horizon. Future astronomers, living trillions of years from now, will look out at a sky containing only their local galaxy. The merged remains of the Milky Way and Andromeda, and a few smaller companions. Beyond that, darkness, nothing. They will have no evidence that the universe ever contained anything else. The cosmic microwave background will have stretched beyond detection. The light from distant galaxies will have faded forever. All the proof of the Big Bang, all the evidence of cosmic expansion, all the information about the true nature and history of the universe will be gone. If you sent them a message describing trillions of galaxies and an expanding universe and a cosmic microwave background, they might think you were inventing myths. They might assume their ancestors were confused or superstitious. The truth would seem like fantasy. This is one of the most poignant implications of the cosmic edge. Knowledge can be lost, not through forgetting or carelessness, but through the fundamental physics of the universe. The expansion that defines our horizon will eventually erase the evidence of its own existence. The universe will hide its own story. We are the witnesses. We live in the era when the story is still visible. The cosmic microwave background still glows in our telescopes. Distant galaxies still sparkle in our deep field images. The expansion is still measurable, the acceleration still detectable. We can see what future generations never will. This gives our era a special significance. We are the cosmologists of the Golden Age, the astronomers of the window, the generations that can piece together the true story of the cosmos, because the evidence has not yet been erased. What we learn now might be all that is ever known about the true universe. If we preserve our knowledge, if we pass it down through whatever transformations humanity undergoes, if we somehow keep the record intact across billions of years, then future beings might know the truth even when they cannot see it. We could be the bridge between the visible cosmos and the dark future, or the knowledge could be lost. Civilizations could rise and fall. Records could be destroyed. The chain of transmission could break. And then the truth would be gone forever, replaced by whatever limited picture the far future allows. This is the weight of living at the edge, the responsibility of being witnesses to something transient. The universe in its current form is not permanent. The edge is moving. The story is being erased even as we read it. So we should read it well. We should learn everything we can. We should build better telescopes and develop better theories and push the boundaries of understanding as far as they will go. Not just for ourselves, but for all the minds that might come after. For all the beings who might inherit our knowledge if we are wise enough to preserve it. The edge of the universe is stranger than you can imagine, but you have spent these hours imagining it nonetheless. You have absorbed facts and concepts and images that describe the cosmic boundary. You have let the strangeness wash over you and found, perhaps, that it is not so overwhelming after all, that the human mind can hold the cosmos, at least in part. That understanding is possible even at the edge of everything. This is your inheritance now. This knowledge, this perspective, this sense of cosmic wonder. You can carry it with you and share it with others. You can be part of the chain of transmission that keeps the truth alive. The universe made you. Hydrogen and helium from the Big Bang, heavier elements from the cores of stars, complex chemistry on a rocky planet, evolution over billions of years. All of it leading to this moment, to you, lying here contemplating the edge. You are the universe looking at itself. You are the cosmos made conscious, and consciousness is what makes the edge meaningful. Without observers, there would be no horizon. The universe would just be stretching out in all directions, with no one to notice where visibility ends. But you notice. You ask questions. You feel wonder. You transform mere existence into experience. This is the deepest magic at the edge of the universe. Not the physics, though that is magical too. Not the numbers, though they are mind-bending. But the fact that the universe has produced beings who care about the edge, who want to know what is out there, who feel something when they contemplate the cosmic horizon. You feel something right now, I can tell. You would not have listened this long if you did not. The edge has touched you. The strangeness has left its mark. You are different now than you were when we started, even if only slightly. The cosmos has changed you. Let that change stay. Let it inform how you see the world tomorrow. Let it remind you, in moments of difficulty or despair, that you are part of something immense and beautiful and strange. Let the edge be a touchstone, a place you can return to in your mind when you need perspective. The stars will still be there tomorrow. The cosmic microwave background will still be raining down. The edge will still be receding. Galaxies still slipping away. The universe still expanding in its strange, accelerating dance. And you will still be here, for now, in this brief and precious moment of cosmic history. Make the most of it. Ask questions. Seek answers. Feel wonder. Be alive to the mystery. The edge is there, always there waiting to be contemplated. And you are here, capable of contemplation. The two belong together. Thank you for taking this journey with me. From the first hook to this final moment, you have been my companion in exploring the edge of everything. I hope the journey was worth it. I hope you found something here that resonates, that stays with you, that makes the universe feel a little more wondrous and a little more strange. The edge of the universe is stranger than you can imagine, and now you know why. Sleep well, cosmic traveler. The universe holds you in its vast embrace. The edge surrounds you, defines you, and makes your existence possible. Rest now, dream deep. And when you wake, remember, you live at the edge of everything, and that edge is beautiful. Good night. The ancient photons continue their journey even now. They have been traveling since before Earth existed, since before our sun ignited, since before the Milky Way took its current shape, and tonight, some of them complete their voyage, ending in telescopes and detectors, and yes, even in the cells of your body. You are made of stardust, they say, but you are also touched by edge light. The cosmic microwave background passes through you constantly. You are connected to the beginning of time in the most physical way possible. Particles from the edge interact with particles in your body. The boundary is not distant. It is intimate. It is here. Sweet dreams, child of the cosmos. The edge watches over you tonight. Until we explore again, rest peacefully among the stars.